Okay, so this is going to be a video tutorial about how to use Fusion 360 and Inkscape to prepare for the plastic mold injection lab. So there's a few things that you're going to need to have set up beforehand in order to work your way through this tutorial. The first is having Fusion 360. We're also going to be using the Shaper add-in to help us export to an SVG as we kind of bring our file to do some additional work in Inkscape, which means you'll also need Inkscape. To get this Shaper add-in, you can actually just, in Fusion 360, if you go to add-ins, you can open up the App Store and just look for Shaper, and you can go here and you can select the Windows or the Mac version, just depending on your operating system, and then download and install. Once you have that downloaded, if you go to add-ins and then you can click on this option here, you can then go over to add-ins, find the Shaper utilities and just hit run, and it'll add it to your toolbar here. You'll also need Inkscape, and so make sure that you have that installed and just have a kind of a blank sketch. We'll be getting that toward the end of our tutorial. And if you have those things, you should be in good shape. So the sample that I'm going to be demonstrating on how to make today is just a simple hand tool. So that's the constraint of the design activity, is to make a hand tool that can be plastic mold injected. And I just did a little sketch here of what I envision my hand tool to look like. It's going to be a little tool for loosening the most common size bolt on my car. It's a 5/16 bolt, and I imagine it as something that could hang on a key ring, or you could throw in your glove box, and anytime you needed to loosen or tighten those bolts, you'd have this handy tool nearby. So to sort of figure out some basic dimensions, we know that this hand tool needs to be constrained to 3 inches by 3 inches by 1/2 inch thick, so you can't go outside of that. And so I came over to McMaster Car and actually pulled up the dimensions of this bolt that I'm trying to work with, and I see that it's got a kind of a 1/2 inch diameter hex head on it. So that's kind of the constraints that I'm going to be working within. And so my goal is to kind of model this a little bit more precisely in Fusion, and we'll kind of walk through some of the tools and steps that you'll need to kind of create your own hand tool that will help you do this lab. So I'm going to hop over into Fusion 360, and I've just got a blank sketch here. And the first thing that I'm going to do is I'm going to sketch out kind of the constraints of my workspace. To do that, I'm going to click on the 2-point rectangle tool up here in the sketch panel, and I'm going to select just this kind of base plate to work from. I'm going to start from the origin, and I'm going to type in 3 inches by 3 inches, since I know that I can't be outside of that, and hit enter. And one of the things that I want to do is I want to make sure that for these guidelines that I'm creating, that they are construction lines. And so I just kind of selected those 4 edges and clicked on this construction tool here because these lines aren't going to be part of my final design, and so I just want to kind of distinguish that by making them construction lines. And to start off with, a lot of these lines that I'm going to be making are construction lines, and we'll kind of go back over them with real lines that we'll use in our final design. So going from there, I've got this 3 inch by 3 inch space, and I'm just going to begin to kind of create just some very basic geometry. So I'm going to come in here and grab a center diameter circle, which you can select from this menu, or you can see that there's a hotkey C that will give that to you automatically. And I'm going to come in here, and I'm just going to kind of create a circle here and start to kind of work out some of the basic geometry that I defined in my sketch. So this is kind of the main part of the handle. I'm going to come over in here, and with this is going to kind of be the opening for the keyring. And for the plastic mold injection, you're not going to want any openings that are less than a 1/4 inch. At that point, you're just getting way too small, and it's not going to laser cut or inject properly. So I'm going to make this opening for the keyring a 1/4 inch. And I'm also going to kind of create some additional geometry, about a 1/2 inch, that's going to kind of help create an opening, again, about a 1/4 inch wall thickness there, so that we've got a good amount of plastic for that keyring to go onto it. So this is kind of the handle and the keyring part. I'm going to use a polygon tool, and again, for now, I'm just going to make these lines construction lines, because again, I just want them as kind of just helpful guides for now. And so we'll come over here to polygons, and I'm going to use the circumscribed polygon. I'll come about halfway here, and you can see by default it has 6 sides. You could change that if you want, but since I'm using a hex bolt, I want 6 sides. And I knew from the McMaster car documentation that it had a diameter of a ½ inch, and so this is kind of wanting me to give it a radius. And so I know that the radius is half of the diameter, so I can just type in 0.25. And I know that that is kind of roughly the size of that hex bolt that I want. Again, we'll make that those construction lines for now. I'm going to do that same thing again because that's kind of the part that's going to be taken away, but I need some thickness, and so I'll come over here to circumscribe polygon again. And this time I'm going to make one that's kind of similarly sized at 0.5 inches. And again, just want to make sure that those are construction lines for now. Okay, so I can see kind of this basic geometry coming together. And to make my tool a little bit more ergonomic, I'm going to start actually sketching the lines that I would like to laser cut. And for that, I'm going to use what's called a spline, and specifically a fit point spline. And this will give you nice curved edges. And so what I'll be able to do is kind of click along this geometry here, and it'll create some nice curved edges that will help me define the shape of my tool. So what I'm going to do is I'm going to start here at kind of the opening of the device. And I'm just going to come across here, and you can kind of see it beginning to kind of create the basic geometry here. So I'm going to come across and just click on a few points. And as I come around the other side, notice how I'm trying to be somewhat symmetrical with the points that I click. And so if I click in here, and I'm done now, so I can just hit enter, you can see that it gave me a nice, kind of very nice curved shape. Okay, so I didn't want to continue that spline into these hard edges because it would make them curved. And so instead, what I'll do is I'll just use the line tool, and I can just click. And what's nice about having these construction lines here is that our line tool just will snap onto those perfectly. And as soon as I kind of close up that space, you can see this whole thing turns this brownish tan color to let me know that I have a solid surface that I can begin to work with. Next thing I'm going to do is I'm going to come over to this interior circle that I'd created, and actually I want to keep that one, so I don't have to make that a construction line anymore. It can just be a regular line. But the next thing I want to do is I want to kind of cut out this shape here for the interior handle. And the way that I'm going to do that is I'm going to come back over and use my spline tool, and I'm going to kind of start a little bit of ways from where that opening is going to be for the keychain, and I'm just going to begin to just click along this edge, and you can see that it starts to make a nice curved opening. And as I get closer, I'm not going to go right to the edge of that keychain. I'm going to come up just relatively close to it and then click on this surface. And what you can see is the benefit of doing that is it gives me just a nice curved edge to work in. So I'm going to kind of close that out, and at this point you can see that I've got just a nice piece that I can begin to extrude now. So having come this far, you'll notice that it says Untitled. I do want to save this, and so I'm going to click Save, and I'm going to call this Tool Sample. You can call yours whatever you want. And at this point, I need to extrude this. Now, we got to be very thoughtful about the thickness that we extrude at. The acrylic that we're going to be cutting is 0.125 inches, so 1/8 of an inch. And so any thickness that we extrude this to needs to be a multiple of that. So it can be 0.125, it could be 0.250. I'm going to make mine a little bit thicker, and so I'm going to click on this face and click on this extrude button, and I'm going to go to 0.375 inches and hit enter. And here you can see a nice kind of 3D rendering of what my hand tool would look like. And that seems to be pretty appropriate just based on the constraints of what I'm trying to create here. So at this point, we've got a rough sample here. Now what we want to do is this is three-dimensional, and what we need is this to be a two-dimensional rendering that we can use with the laser cutter. And so one of the things that we can do is we can just select this top face here, and if we click on the shaper, add-in, it's going to allow us to export this as an SVG, and that'll help us bring it into Inkscape so that we can kind of create the laser cut files that we're going to need to cut. So I'm just going to click OK, and I'll save this as tool sample again. And we'll get back to that in just a second on kind of how to modify this in Inkscape. But while we're here in Fusion 360, I want to show you how to do a few of the other requirements for the assignment. So I'm going to go ahead and save. So one of the other requirements is that we do a rendering of our object. And this can be good for including in a portfolio, but also to kind of give us a nice idea of kind of what the surface quality is going to be of our final part. And so if we click up over here on Model, and we come over to Render, you see that it's going to kind of throw it on the stage and already add a little bit of lighting effects and shadow effects. And so I'm going to walk you through just a few simple steps in order to get this to be a photorealistic rendering. The first thing that we're going to do is we're going to click on this icon here for Appearance. And this is actually going to let us select a material that we're going to make our object out of. And so right now, it looks like it's choosing some sort of metallic finish. We're working with plastic, so I'm going to come over here to plastic and opaque, and we can choose a lot of different options. So depending on what you want to work with, I'm going to choose how about a glossy white? And so I can just click and drag that, and if I just drag it onto the object, you'll see that it'll immediately change its appearance, which is very nice. Next thing what we're going to do is we can close this down, and I can click on our scene settings. And this is going to kind of think about this as the stage that we are taking a photograph of this on. You can see that just by default we've got some options selected. I'm going to add reflections, so that sometimes can add a nice little reflection on the bottom there. And you can choose everything from an environment. For now I'm just going to choose a solid color background. You can choose whatever that is. So if you wanted it to be a white background, you could. If you wanted it to be a black background, you could. But I kind of like the gray background, so I'm going to kind of go back to that. Maybe a little bit lighter there. So that's good. That's going to just show some nice contrast with my material here. So once you have that kind of in the orientation that you want, you can click Close. And so now what we're going to do is we're going to go to the Render tab. Now with the Render tab you get lots of options, and you need to be thoughtful about choosing these settings because again, thinking about kind of what you're going to be turning in for the assignment, but also what may look good for a portfolio later on. So I'm going to come over here to Print, and I'm going to choose a 4 by 6 inch. And again, if you're thinking about maybe making this a full-size image, you could definitely go bigger. But there's always a trade-off with, if you go bigger and higher quality, it's going to take longer to render. So for now, I'm just going to, for this demonstration, I'm going to stick to this 4 by 6. You do want to use the local renderer. The cloud renderer uploads it and it gets done on Autodesk's servers. But the trade-off with that is it costs money. So we're going to render it locally, and this could take anywhere from a few seconds to a few minutes depending on the quality of your laptop or desktop. And for render quality, I'm going to just choose standard for now, just because this is a demonstration. So here are kind of the settings that I'm using, and again, you can play around with it just depending on what your final use for the photorealistic rendering is going to be. So I'm going to click Render, and it's going to start. And once it's started, down here in this called the Rendering Gallery, it'll show you the progress of that rendering. And we can see that it popped up there. For the assignment, you're going to want this isometric view, so essentially being able to see it from kind of an elevated angle. You can achieve that by just clicking kind of on the home icon here. You could render additional views if you wanted, so you could do a top view, or a side view, just depending on the geometry that you want to show off in yours. But for the assignment, you need to at least have one rendered image of an isometric view of your device. Okay, so that's going to take a little bit of time, and that's fine. We're going to go ahead and save again. It's always good to save between these operations. If Fusion crashes for some reason, you don't want to lose all of your progress. So while that renders, I'm going to show you one more thing that you're going to be doing for the lab, and that's going to be a simulation. And the simulation is going to kind of explore some of those material properties that we'll talk about in class, and kind of seeing how the tool will react to certain stresses. So the simulation that we're going to do for this assignment is a static stress test. So essentially, just if you were pulling on it or pushing on it on one particular area, what would it do to the device? So we're going to choose the static stress, and we're going to do create study. Okay. Now the first thing that we need to do, just like in the render tab, is we need to tell Fusion 360 what material we're using, because if you're building this out of metal or glass or plastic, the way that it's going to react to those stresses will be different based on that material. So we'll click here on this materials tab, and you'll see again by default it's set to steel, but we are not making this out of steel. We're actually going to be using polypropylene to do our plastic mold injection, and you can see that listed right here. And so we're going to click on polypropylene. And the safety factor, this is kind of what we're studying, and we are going to be looking at yield strength. So at what point will this kind of go beyond elastic deformation? And so we can go ahead and click OK. And so now it knows that we want this to be made out of polypropylene. The next thing that we need to do is we need to build in a constraint, a structural constraint. And what this is going to tell Fusion 360 is kind of like, as we begin to do a test on this, what part do we anticipate is not going to be affected by the force? Now for my study, I'm going to be thinking about if I attached a keychain kind of through this keychain hole and pulled on it really hard, at what point would this be beyond the breaking point? And so as I'm looking at that, I can imagine that the surfaces that are going to be affected, this top side may get stretched out, this edge definitely would get stretched out, even the bottom would get stretched out. But the part of this model that doesn't seem like it's going to be affected by that force is this inside loop right here, since I'm going to be pulling kind of outward. And so I'm going to use that as my structural constraint. So I'm just going to click on this and say that I don't anticipate that that side is going to get moved very much in my test here. So I can go ahead and click OK. Now we need to add our structural load. So this is the force that we are going to be applying to our model. So I'm going to click on this. And for this, I'm going to be applying that force to this inside here. Since if you were to attach a key ring to this and pull on it, you would imagine that that's what's going to be kind of feeling that force. So you can go ahead and click on that. And you can see that it gives you an arrow. And you can change the direction of that force. So I imagine mine's going to be going a little bit outwards, so I can change it that way. And we need to give it a magnitude. Now in this case it's in terms of newtons, and that's fine if you want to do it in newtons. I'm going to change mine to pound force, and I'm going to say what would it be if I gave it 150 pounds of force in that direction. So if I click OK, so with this I've got my material set up, I've got my constraint set up, and I've got my load set up. At this point I should be okay to go ahead and run the simulation and see what's going to happen. So I'm going to click on Solve, okay, and it looks like it does say that it's ready, that there's no issues that it's found with it. Again, we're going to solve it locally. We don't want to do it on the cloud. And I go and click Solve, and it will take a little bit. Now, when you're doing this, it may need to load just some simple files to help it solve this, which is essentially just big math equation. But after a few seconds or a few minutes, you should see that you get some results. And in this case, it looks at all the ways in which it's deforming, and it kind of creates this minimum safety factor. And it says that my design is marginal, meaning that if I were to apply that kind of force, it may actually bend or break, which seems to be reasonable if you made a little keychain out of plastic and you put 150 pounds of force on it. It's not surprising that you may bend or break it. And you can see that I was actually pretty close. I was almost to the green. If I dialed down that force to 100 pounds or 125 pounds, I'd probably be safely in this green. But this is a good way to visualize what's going on with our device. And here you can actually see how it's been stretched out and deformed that shape to the point where it says that you probably shouldn't put 150 pounds on this. So this is good. So at this point, what you'd want to do is you want to take a screenshot of this, because you'll need to include this for your write-up as well. And so I'm going to take a screenshot and get all this information in it so I can show the results of my study, and I'll include that in the lab write-up as well. Okay, so that's our simulation study. Let's go back to our rendering and see if we have a finished rendering. Oh, and it appears that we do. So the status bar has kind of completely updated here, and if I click on this, and you should see that we get a nice rendered image. And I can download this to my desktop, and again, I'm going to save this and include it for my lab write-up as well. So at that point, we should be good with Fusion 360. So we've got our exported SVG that we're going to kind of jump into Inkscape to play with now. We've got our rendered, and then we have our simulation all set up. So at this point, we can go ahead and just save if we need to save. and we can jump into Inkscape and start getting our model ready for laser cutting. Now, to do this, I'm going to just, like I said, I've got a blank Inkscape file here. I'm going to go to File and Document Properties. I'm going to change my units to be inches, both in the default units and in our custom size. And I'm going to just give myself a 12-inch by 12-inch area to work in. I'm going to go ahead and close this down. Okay. Next thing that I can do is I can go to File and Import. And if I go to Desktop, I can hopefully find that tool sample, and I can open that up. Okay. And we'll see that it looks a little bit wonky here. Hopefully we can fix that. So first thing I'm going to do is just ungroup everything and break everything apart. So because when it comes in, it may just be that it has a bunch of parts that are all grouped together. So again, just ungrouping, breaking everything apart. And you can see that here, I'm just kind of selecting everything and getting rid of all of this stroke and fill. So coming down here, okay, see that I've got a lot of stuff going on here, so I'm just going to kind of continue to break apart and ungroup. Okay, and I'm going to set my stroke style to pixels, and I'm just going to make it a single pixels. So that makes it a little bit more manageable. Okay, so here we can see that we've got a nice outline. We can see what the laser cutter is going to be dealing with. And so what we're going to do is we're going to create the individual plates that we're going to stack in order to create our plastic mold for injection. Those plates are going to be 4 inches by 4 inches. And so I'm going to just create a plate right here and come up here and just manually set it to 4 inches by 4 inches. And we need to be careful as we kind of position things that we are very intentional about how we're placing our shape on this plate. So now that I've got this looking the way that I want to, I'm going to go ahead and highlight everything, and I'm going to group it together again. And what that is going to allow me to do is to select both of these objects, and if I come into the Align and Distribute panel, I can now center these together so that I've got my mold kind of perfectly centered where I want it. Okay. Now we know that, as I kind of mentioned previously, that I'm going to make this 0.375 inches tall, and if these plates each are 0.125, that means that I'm going to need 3 of these plates in order to get the desired thickness for my mold. And so I'm going to go ahead and create 3 of these. Okay. So that would take care of this. Now, what I also need, however, is I need a bottom plate where we're going to be able to hold in all the plastic mold that's kind of getting injected into it. I need a top plate as well that can be affixed to the mold injector. So I'm going to create 2 more of these. So I'll just put one there and one here, and I might do a little bit of rearranging to make things fit nicely. So actually I'm going to come in Document Properties, and I'm just going to expand this out to 13 inches by 13 inches. Okay. And so I know that, like, well, we'll make these 3 on the bottom, the ones that are going to just be the standard molds. We'll make this one right here the top mold, and this one here the bottom mold. Okay, so as I'm thinking about this, I need to think about where do I want the plastic to go. Well, in this case, when we're injecting the plastic, we want it to go in this area right here. And so I'm going to create a little porthole here that is going to allow the plastic to flow into the mold. Now that porthole needs to be of specific size, so we're going to make it 0.25 inches in both dimensions, and that's what's going to allow the plastic to actually get into this area. That being said, so this is our top, so we don't actually need this anymore. So this is our top piece, and this is where the plastic is going to flow into it. On the bottom, however, we're going to create small little holes that will, as the pressure builds up inside this mold as the injection process is occurring, we want to be able to relieve some of that pressure and allow the air to escape. And so we're going to position some small escape holes in here to allow that air and pressure to escape. In this case, we're going to make those 0.0625, so that's a 16th of an inch, 0.0625. Okay. And we actually want a few of these, so I'm going to put them kind of around here. Okay, so I've got 1, 2, 3, 4, 5, and that will just allow that air to escape and to relieve some pressure. Okay, again, I don't need this anymore. Okay, and so you can see that right now I've got my 5 plates needed. I've got my top plate, I've got my 3 middle plates that are kind of that negative cavity where the plastic is going to flow, and I've got my bottom plate here where we're going to be able to relieve that pressure. Okay, so I'm going to go ahead and save this, and we'll call this tool cut. And the last bit that we need to do is we need to actually export this, or rather save it as a DXF. So I'm going to call that tool cut DXF. Now it may seem strange that we went from kind of a Fusion 360 model to SVG to DXF, but I have found this to be kind of the most reliable way to get your model passed between the different software programs. So we're at toolcut.dxf. I'm going to save. You want to make sure that you're saving base units in inches and that none of these checkboxes are checked. You want those unchecked. And if you click OK, what you should kind of finally come to is a toolcut.dxf, and that's what we can take over to the laser cutter and cut on our acrylic. And that should take you over to the next step, which is going to be assembling the mold with super glue, attaching it up to the plastic mold injector, and injecting your tool. And that's it.